Hi and welcome to my maths class. Today we're doing another theorem that is very similar to the midpoint chord, but it is actually a converse of the midpoint chord. Now in the midpoint chord, the two things they gave us was the center and the midpoint. Now look at the difference. It says if a line is drawn from the center, so again they've given me the center, and it is perpendicular. So if a line is drawn from the center of the circle perpendicular to the chord, then it bisects the chord. Look at the difference. They are giving me a center and they are giving me a perpendicular. Whereas in the previous videos we've learned, they have given us the center and the midpoint. You have to know both these theorems for examination purposes in the final metric paper. So it says, if a line is drawn from the center of a circle perpendicular to a chord, then it bisects the chord. So again, when we're starting, we're going to start with what is given. Remember, when we're doing proofs, the style will always be very similar. What have they given us? They have given us the center, and they had told us that OM is perpendicular to NL. So OM is perpendicular to NL, meaning it is 90 degrees. Now remember, I told you when we're doing riders, we have to refer to the theorem, but we don't go about referring to it as theorem 1, theorem 2. We go and they all have specific names. Now this specific name is called perpendicular from center to chord. Perpendicular from center to chord. That is the name of this theorem. The one we've done in the previous video was midpoint chord. Know your theorems. If it means you take a page and you put all 9 theorems on the page just with the drawings and the short form names, you need to start knowing. The best way to do riders is to be able to wrap off all your theorems under a minute. You must be able to say all of them under a minute. Right, so what are you given? You are given the center and you are given that OM is perpendicular to NL. Remember, don't get comfortable with our alphabets or the alphabets in the textbook. The department can change it as they want. So what do we want to prove? We want to prove that NM is equal to ML. We want to prove that the line is bisect. So NM is equal to ML. How do we start doing this? First, we're going to construct. We are going to construct line ON and line OL. Remembering that these are radius. Alright, now how do we go about proving this? It's very similar to the previous proof we've done. You are trying to prove that the one triangle is congruent to the other. So what triangle are we working in? We're working with triangle OMN and triangle OML. Right, we have that ON is equal to OL. Reason, radius, right? Then we have that OM is equal to OM. It's common. It is in both triangles. And last, we have that M1 is equal to M2. Now did you notice I put in the 1 and I put in the 2? Sometimes the drawings will not have these numbers, but these drawings will be given to you as a diagram sheet in your matric exam. And this diagram sheet is handed in. So the examiners see what you write on your diagram. So you make sure to fill it in onto the diagram that you are handing in. Don't fill it in on your examination question paper. You don't hand that in. You fill it in either in the examination writing material document they'll put in, or they will give you a separate paper. But either way, it would be there. It would state clearly, put your exam number, and you hand in this paper, or you hand it in on your writing material, not your examination question paper. And once you fill it in, then you can write. M1 is equal to M2, and this was given. How do we know it was given? Because they said it was perpendicular, and perpendicular means it's creating a 90-degree triangle. So we now have that triangle OMN is congruent to triangle OML. And what is our reason? 90 degree, because we had a 90 degree hypotenuse side. We had used the hypotenuse side and we had used another side. So it's 90 degrees hypotenuse side. Again, congruency is discussed in your grade 10 videos. Now, since it is congruent, we can now deduce that NM is equal to ML, which is exactly what they had asked us in the beginning. This is what they had asked us to prove. Thank you for watching.